All right, so hi everyone. My name is Chen Huey. Work at the Not Worldwide, and I'm going to talk about using Kubernetes to reduce infrastructure costs and increase your engineers' productivity. So a little overview about what we're going to talk about. A little bit of introduction about my company, a little bit of introduction about myself, and then we're going to talk about how we do DevOps, and then why we chose to move to Kubernetes, and then our experience doing so, some lessons learned from our migration, and why we're doing all of this. A little bit about the Not Worldwide. Our mission is to help people navigate life's biggest moments together. Our web and mobile properties help people plan weddings and other life events. In terms of our size, just to give you an idea of what we're talking about in the scope of our engineering organization, we're about 120 software engineers, and then the company is about 1,000 people overall. A little bit about me. I'm a senior software engineer here. My primary responsibility is the DevOps for our US based brands, except for Wedding Wire. They're on a little bit of a different platform. So I've been in DevOps or infrastructure since the early 2000s, both in the data centers and cloud. Now it's mostly cloud, and I don't really miss being in the data center all that much. I started my career as a Java J2EE developer. So a little bit background about myself. In terms of how the Not Worldwide does DevOps, it's a little maybe different than how traditionally people do it. Our product engineers, so the engineers who are developing the platform and our web and mobile properties, they do have full autonomy and they have their own AWS accounts. What we as the DevOps team, or what we call in my company engineering productivity team, does is that we develop the common tools, best practices, platforms that allow, they're like designed to be self-service so that the product engineers can do what they need to do easily with very little friction as possible to accomplish their goals. So that's kind of how, when we were pitching Kubernetes, it would be something that we as a centralized DevOps team would manage, and then the product engineers would manage everything else. So they generally create the databases and the Elasticsearch, Elasticache things, and they manage those in their own account. So that's kind of how our infrastructure or DevOps expertise is split up. In terms of why we picked Kubernetes, we'll go into a little bit of that, and then why we had to do this. Um, but first, I think all of us kind of struggle in technology with, we see something that's cool and we're like, ah, that's really cool. Like, I want to do this. But, at the end, like, it has to be for some benefit to the business, right? Like, you can't, sometimes you go down these rabbit holes doing cool things for coolness sake, and then it becomes like a waste of time if there's no benefit at the other end. So in terms of like uh, for Kubernetes, like especially why we had to make a case for it. And the audience for this is usually the product managers and the tech executives. So in this terms of tech executives, it's the VP of engineering, or like your CTOs, and then it's the product managers. And you might ask, like, why do they get involved? At least how the Not Worldwide operates, because Kubernetes is this common platform that everyone uses, it's such that you know people will, you're going to need product engineers to spend some time migrating, whether they're migrating their deployment jobs, whether or not they're taking out time so we can retrain them in the new way of deploying. Because it's a deployment platform that everyone uses, there's going to be some l- time that they're going to need to spend like doing those activities to migrate, that they're not going to be spending developing product. So is there some benefit to be worth the time that there's the opportunity cost that they're not spending, developing product? And that's really why, in this case, especially, that we had to make a case for it, to the business. So what was our case? So back in the mid 2017 timeframe, we had two objectives that we felt we could accomplish with Kubernetes. The first is a very obvious one. I'm sure everyone has this somewhere on their list. It's one of our team's uh, charters, is to reduce um, infrastructure costs. Right, like we had low CPU utilization, so obviously we were wasting a lot of CPU. So we want to increase the utilization and lower our costs, right? Use our infrastructure more efficiently. In terms of, we did have one lever to push, which is reserved instances, but at the time it's a bit time consuming. And as I'll get into later, there's limited flexibility in how to do that. The second half of it is that the old way of deploying is Elastic Beanstalk, and one of the things that I think it's kind of notorious for is the deployment slowness. So any gain that we can get in deployment speed, because at times it would take quite a long time to deploy, that would free up engineering time for feature development. So that was the other main case, and I think in some ways the more compelling case for moving to Kubernetes, if it was able to reduce that time. So I'll drill into these two things a little bit more. So in terms of cost savings, it had to do with kind of three aspects. So the first aspect is being able to stack more than one container um, onto onto the instances that we're running, right? So when we proposed Kubernetes, 80% of our workload was on a single container Elastic Beanstalk. What that means is that there's one Docker container for every instance, which isn't very efficient at all. The rest of it was on Heroku. Um, so, and this, like the single container Beanstalk becomes an issue because our architecture is mainly microservice. So what you end up having is that oftentimes the microservice was so small, so micro, that it was much smaller than the smallest available AWS instance, right? We'd have, I think the smallest one you could get is either one or two vCPUs, but we had microservices that would require like much less than that, like a tenth of a CPU or something like that. So we were obviously, the one-to-one nature of it, we wasted a lot of infrastructure doing that. The other thing which has cost implications is that every Beanstalk application has an ELB, right? An ELB costs roughly, at least in USD to one, about $15 a month. And so you're in that cost whether you have one instance or five instances. It's the same fixed cost that you're in. So Kubernetes, we felt, would solve these issues by it by default, with very little interaction, um, schedules multiple containers on nodes. Right. That's if they're appropriately sized, that's what's going to happen. We also felt that we were going to be able to standardize the deployment using a company specific Helm chart, and that would reduce both the amount of files, and I'll show this later, that engineers had to uh, manage, but also Helm would eliminate the need. Like the only thing the engineer would need to know how to use is Helm, and even then, how to integrate it into CI/CD in order to deploy applications, which is the main thing that they need to know. They don't really need to know the full Kubernetes toolchain. And the last thing is, along with that Elastic load balancer issue, is that the clusters can share an ELB, right? The cluster, you can install an ingress controller, and so that would handle all the inputs and direct and do the service discovery for all the various applications you're running on a cluster. So you're saving that $15 a month for every application that you're running, right? So that was that case. The next case we looked at was the ability to run spot instances, right? So as I described before, there's lots of product teams. They each have their own AWS account. They're running beanstalks in each of these accounts. So you have very disparate um, compute, right? All your compute is on these separate beanstalks all over the place. And where Kubernetes would come in is that it would give us a centralized block of compute that we manage. And with spot instances, for those of you who don't know what they are, it's their excess capacity that AWS has that they offer at usually pretty deep discounts. The catch is that uh, if they need that instance, they get it back, and you have, I think, 2 minutes to give it back, and it's not you giving it back; they just take it from you. Um, so you can understand with that paradigm, you're going to have strategies to deal with that. Well, in the case of Beanstalk, it's who takes that on, because if a team has 10 beanstalks, like, do they manage it? And then all of those changes, all of implementing those strategies to deal with, like, a paradigm where, hey, you might lose your instance and you have to figure out a way to replace it. Like, you're going to have to do that 10 times, right? In some way or another. Or, like, there's going to be automation. But it was definitely something we didn't implement necessarily because it was such a big problem, because we had all this disparate compute, and Kubernetes would centralize that. Um, and so, that was another thing that we looked at. And I have some stats on the screen about what the savings is. It's about, if we were using reserved instances, which we were using, you're saving about a third. And then on top of that, you can save anywhere from 20 to 50% using a spot instance. So the last thing is, in terms of cost savings, being able to optimize our instances, right? So, like I said, we were using reserved instances. Um, they do offer savings. Like I said, it's about a third. But the catch is that the shortest term you could get is a year, which means that if your application has time of day or seasonal traffic changes, or there's specific things, like we had the old homepage Rails app. It's no longer a Rails app, but when we did have it, it needed 2 gigabytes of RAM to start up. And then the frustrating thing is that when it started running, it only needed about 300 megs to run. So between those two things, and for our load, uh, based on time of day, it tends to go up as the day goes on, with it kind of peaking in the evenings and at night. And then seasonally, our traffic tends to go up around the end of the year and the beginning of the year. Well, how do you manage that, right? Like, if you have a reserved instance that you're committed to using, right? Um, it's gonna you're gonna have that no matter what, right? Now, potentially you could say, all right, I'm going to have a base level of RIs, and then anything else is going to be on demand. Well, if you do that, you might wipe out all your savings from your reserved instances. So where Spot comes in is that, because there's no commitment, there is potential savings, because you could establish your baseline as RIs like you would, and then anything that's peak, right? So we could have, let's say, you know 5 instances for the rest of the day, and then at night we'll just scale up using spot instances, and then we're getting savings rather than having to run on demand. So that's kind of what we're talking about, in order to uh, optimize our use of compute, um, as well as maximizing the amount of compute where we're saving something over the on-demand pricing. um, The next half of it is being able to increased engineer productivity. And what this means is really freeing up engineers' time from doing kind of mundane tasks of setting up deployments or waiting for deployments to finish so that they can use that time to develop features and do the engineering work that drives revenue, right? So, like I said, the main pain point for us with Elastic Beanstalk is the time it takes to deploy. And this was really driven by the fact that, like, a lot of times Beanstalk, and especially I think when you're using Beanstalk extensions, which we use quite extensively, it doesn't just swap out. So we're using Beanstalks with Docker containers. So they're not just when you're doing a deployment or a redeploy, um, they're not just swapping out the Docker container, they're swapping out the entire instance, right? And so you can imagine in production where you have many instances and that when you're doing a rolling update, it could take a long time because it's not the Docker container that's the bottleneck, it's the instance coming up, right? So we had instances of like deployments taking typically 15 to 20 minutes, but the larger deployments with more instances, more replicas would take 30 minutes. In some extreme cases, like 45 minutes. And that was all time that, obviously the engineer doesn't sit there waiting for it. You would hope they wouldn't, but they would get distracted or they would work on something else, forget about it, and then have to go back. It just was a context switching and just a lot of waste. So that was really what we're trying to solve. And so Kubernetes solves this because it decouples, right, that Docker container from the underlying infrastructure, right? There is nothing in a Helm chart deployment in Kubernetes where an engineer deploys an application where they're affecting the underlying infrastructure, right? They're not changing any load balancers. They're not certainly not spinning up any instances. I mean, they might end up triggering an auto scaling event where additional instances are created, but their action by itself, right? If nothing else happens, is just deploying containers, right? And we know that deploying containers is a lot faster than spinning up instances. The other half of it is that, you know, I mentioned that we want to develop a company specific Helm chart, right? And that really has two objectives, right? One, Elastic Beanstalk, if you're familiar with it, there's a lot of EB extensions, right? And certain things like setting up memory metrics is even more significant, right? Create, you have to install an agent, and you also have to like um, add, add CloudWatch dashboards and all those things, right? The other thing is just that there's lots of files to maintain. So what we were looking to achieve with the Kubernetes ecosystem with Helm charts is that there'd be a standard deployment. Engineers would manage one YAML values file and turning on specific features. Some of them they would get built in as part of the Kubernetes ecosystem. So the others would be, things that they could turn on with a couple of lines in that YAML file. So that all these things would add up to freeing up time for developers. So, like I said, this was back in 2017 that we started all this and pitched it. And so, what was our experience? It's probably been like 2.5 years since then. So, in terms of what happened after we migrated and started running our first applications in production on Kubernetes in uh, the first quarter of 2018. At this point, we have roughly about three quarters, 80% of our US properties that the team I'm part of managing is running on Kubernetes, right? So we did analysis in about a year in 2019, I think in April, of what the reduction is once we had kind of a, a mass of applications that got moved over because it's been a gradual build over time. Um, and we found that whether we're moving from Beanstalk or Heroku, like the average reduction in compute costs is about 50%, right? And I think much of that was driven by being able to stack more than one container on the instances, right? Like that was instrumental to that 50%. Now, ongoing, we have looked at the effect of, we were also able to implement spot instances. And so we looked at the effect of like, okay, well, now we're using spot instances. How does that compare with the um, other EC2 costs across the organization? So we isolated all our Kubernetes and most of our use of spot instances is with Kubernetes. We're really not using any spot instances outside of that account. Um, so the difference there is about anywhere from 35 to 60%. We vary the amount because sometimes we run more reserved than we do spots, as well as at times when we're turning up new clusters or like new functionality, we do run on demand at certain times to manage our uptime. And So that's why that number varies. Um, in terms of auto spotting, uh, we're using that and using that. It's a relatively safe way to run spot instances, and we're able to run about over 50% of our production cluster on spot instances using that tool. Um, so this is kind of a show and tell version of what I'm talking about of being able to stack containers, right? So what you see here in the red is the IP address of a specific node, right? And if you see on the bottom, I'm doing a kudo command to say, give me all the pods that are across all the namespaces and that are on this node, right? This node with the internal IP of 10.108.5.104, right? And count the number of lines, right? So you see we're packing 32 pods on this node. Now, to be fair, there's a couple of daemon sets, so you could probably say we're running maybe 28 application pods, right? Because there's some system Kubernetes system things that need to run that take up a few pods. But even still, now the other question you're asking is, well, how big is this instance you're running, right? Like, is this we're typically running 4x large instances, and this is pretty much universal. So and to give a comparison compared to Beanstalk, some of the larger Beanstalk applications needed to run on a large instance. So if you had, four of those, right, which would be roughly the same cost as a 4x instance, you're maybe running, you're running four, not maybe, you're running four containers, right? In this case, we're running, let's be conservative, about 28, right? So you see the cost leverage that we're able to accomplish with this. Um, this is just demonstrating. I mean, this is an actual screenshot that I took a couple of days ago of our production cluster, right? So you can see that there's at the time there were 19 production worker instances, 8 of them were reserved, and 11 were spot. And so you could tell that if you look at the cycle column, the normals are the reserved instance, and the spots are spot instances. In our QA cluster, all of our worker instances, and worker instance means an instance where applications get deployed to as opposed to control plane. Um, they're all spot instances. So we get tremendous cost leverage there too from managing everything as a block. So that's pretty much the thing for the cost, and then the other half of it is the productivity gains. And so what we found is that with the not worldwide specific Helm chart, there's been universal adoption, right? And that's been good because you know it shows how frictionless and how easy it is that everyone's used that method of deployment. Like I said, teams have autonomy. Uh, so potentially, if they're like, we don't like your chart, we're going to make our own deployment manifest. There's nothing to stop them from doing that. But no one does that, right? Like it's just shown to be like a very good way of for them to do it, and everyone who's moved to Kubernetes has used it. In terms of the deployment speed, which I said that was one of the major improvements we're looking for Kubernetes to accomplish. Um, Teams that are on Kubernetes are very satisfied, right? No, they're like, this is so much faster. You've unlocked so much time. There are still some teams on Beanstalk, and it's like with any technology adoption or anything else in life, it's it's that bell curve, and so we're at the tail end of the bell curve. There's some people who are clutching on the Beanstalk with for dear life. Um, there's still, in fact, someone told me that it feels they haven't measured it scientifically, but they're like, I think Beanstalk's even slower now. So it is still a pain point in our efforts as the the DevOps team is, we're still pushing and addressing any concerns they have to get that last 20% of people to move to Kubernetes. And it's just something we're continuing to do. The other thing is that um, because we freed up so much time and we have this standardized way of deploying, uh, some product engineers have in the past, and I'm sure in the future, have submitted PRs to the Helm chart repo to add features, right? So that amount of reuse is also a lot of time saved, right? Because in a Beanstalk deployment, because there wasn't one central repo where all these the deployment mechanism lived, right? Oftentimes all those EB extension files are in disparate repos. There wasn't a lot of updating of things. So there was a lot of reuse, and that was a lot of the benefit. So a little bit of what I'm talking about. So you can see on the right, the white side of it, is that Beanstalk is complicated, right? There's all these files, right? The bottom files of the numbers are the EB extensions, and then you have all these YAML files, right? So you have, I think, 9 files in this case. There could be more, right? So you see the 0 to 3, and then the 10. Whereas on the Helm chart on the Kubernetes YAML file, right? You've got one file where you're just turning on these settings, right? And like I said, remember I mentioned that like some engineers developed put pull requests of features onto the Helm chart. Well, you see that high availability flag there? That was something an engineer said, hey, I would like to have a high availability, which means scheduling pods on not the same instance. Like that was something that someone contributed and now is in regular use. You could see that like we're using IAM roles, all those things like, and that helped in terms of having a way for people to use roles to call outside. In this case, it's an Elasticsearch, such that we don't. Well, I think we've pretty much eliminated AWS access keys completely. So those are some of the features that we implemented, which give a standardized way of doing it, uh, and that we never really was able to accomplish, even though we kind of did the same evangelism using Beanstalk. I think one of the big things also is the built-in features. It's we're running Prometheus Operator, which gives us Prometheus metrics and the Grafana dashboard. So this is a little snapshot from there. This cluster-wide view helps like the productivity team, to see trends, right? So what we're seeing right now is that because people are they're migrated their application from Beanstalk, and they're like, hey, I'm running, let's say, a C5 instance, and it's got this much CPU and this much memory. I'm gonna just ask for that much. So our next challenge is saying, hey, you know, start optimizing your use because you're not stuck on these arbitrary AWS resources that are chopped up into these instance types. You can set the compute and memory requests to be whatever you want, right? What works for your application. And as you can see from this next screen, uh, the same metrics mechanism, the Grafana and Prometheus. Also, this is a CPU and memory usage graph, and if you open up the quota and the quota one, it gives you the actual numbers. But engineers can look very simply at, hey, this is what I'm using, so maybe I can tune my memory requests and CPU requests to the level that's shown here. The other thing that wasn't widespread available in Elastic Beanstalk because there was so much friction to set it up is memory usage. And so the important thing to remember is that even though like the my team had to install the Prometheus operator, any application that gets deployed into Kubernetes gets the benefit of all these metrics without the engineers having to do anything. I think pretty much at some point someone did figure out how to get memory usage on beanstalks, but he was the only team to ever have them because I guess it was quite involved. So something like this is a big time saver because it just comes as part of, hey, I deployed an application in Kubernetes and this is what I get. Some of the additional benefits that we got into and weren't pitching, although we did have in the back of our minds that it was possible, but we hadn't gotten around to evangelizing that part because we were busy pushing teams to move to Kubernetes. But the Bash team uh, started using internal routing, right? We did publish some documentation. They saw it and they're like, let's try this. Um, and they said that the latency reduction was substantial, right? They said it was like night and day. So, in terms of what that means, right? So, if you look on a diagram, if you see the blue line that's labeled internal routing, right, and the dotted rectangle, you can view as the. So, if you have an application pod, right, like this deployment B pod one that calls internally, what happens is that it says, okay, uh, goes to internal DNS and says, I want the service, uses the internal DNS name and says, uh, route me to that. What happens is that all of the routing happens internally, right? It happens within the Kubernetes networking mesh. And so it tends to be the fastest it could possibly be. And if by some chance, and you can also schedule this, if the pods are next to each other, you're literally just, it's an inter, you know, inter instance, like, process where you're calling it, right? Um, but at the very least, it's a lot faster than if you went with external routing, which is the red line that says internet routing, where the pod calls out and says, give me the external address. DNS gives it back and says, okay, like this thing has this ELB address, and this is where it is. And it traverses the ELB, traverses the ingress controller. So you could see the potential for all this latency. Um, Now, why is this important and how does this save engineers time? It's the fact that all our teams are measured on performance metrics, right? Like low latency, fast page load times, right? So if by making a very simple change to how they're calling the other services, particularly if the other service is also in Kubernetes, they're going to gain all of this latency. That's more time that they can spend on other things besides making their application faster, right? It's an almost free way of getting speed, right? So I think that's the major savings. Other teams have started moving over, and it again, it's an adoption curve, and we're working on it. My team does have a story to quantify the effect of these changes because the Bash team just did it and was like, oh my god, it's so much faster, and they just kept it, but they never measured it because I don't think they really, especially with many of the other applications, because they're relatively new, thought to measure any of this performance gain. So some lessons learned when moving to my Kubernetes that we found. Our experience is as a centralized DevOps team, like seems to suggest that you know it's best as a common hosting platform, um, and that maybe a centralized team is the best way. And the reason why I say that is because what you find is that a Kubernetes cluster is complex enough and there's significant overhead that it's not something that every team really it doesn't make sense to for them to build, right? Because there's a certain number of instances you're going to need for a control plane, and so if you're a very small application, um, it kind of doesn't make sense. The other thing is that because it's this common platform, perhaps the better way to run it is as a centralized DevOps team instead of a distributed one. I think it's workable, but I think for us it seems to work pretty well. um, the other thing is that it does Kubernetes is complex enough that if you're trying to create a self-service platform, which is really our goal, right? Like both we put the CI/CD, our Jenkins pipeline on Kubernetes, and also the main application cluster. Like it needs additional work. Like whether you're using a managed Kubernetes solution, like we're using for CI/CD, we're using EKS, and for applications, we're using the open source COPS Kubernetes. It's not a turnkey solution, so it's you have to keep that in mind. And along the same lines, it's also for us, we do in a sense have distributed DevOps because engineers spread out throughout the teams do have expertise, but it's really something that a skilled practitioner should use and and operate. And because it's this new technology that's constantly evolving, you do need a certain amount of deeper skill than you may necessarily have in your product teams. So why engineers need to spend doing things, like reducing the friction? It does help, you know, free up more time for them to work. Wrote this feature and deployed it across the Helm chart, like that gain is kind of multiplied across everyone that uses it, right? So that's also a bit of it. Uh, and I'll talk to this, I think it's easy to get caught up in hey, if I'm using spots and I'm using on demand, I'm saving 50% of my infrastructure costs, right? And that sounds like a big number percentage wise, but if you look at the raw numbers, it's really the main gain is from the other side of it, right? So for instance, in the example I gave of your R4, R5 4x large instance, if you ran it a whole day, your savings on demand versus spot is about $12. Our actual savings is less because we're running reserved instances, and really that should be where you're comparing from. But let's maximize it at $12. Well, internally, we assume engineers' time is about $100 an hour. Um, and so if that's the case, and we're saving 15 minutes over Beanstalk, that's a quarter of an hour. So that's $25 per deployment. And depending on how many deployments they do a day, let's say it's just one, it's still a larger percentage gain. And then if you think about what does the engineer do in that, quarter of an hour, or if, let's say they do 4 deployments, it's a full hour that they gain. Like, maybe they're generating a feature that generates more revenue than even that, right? So I think the real leverage there is when you're um, saving engineering time. So some final thoughts. I think, what we experienced was that it does accomplish savings through cost reduction, but I think the more significant gains are from freeing up engineering time. I think it does work best when you have enough uh, workload for it to make sense, because it is complex and uh, there is overhead to Kubernetes. And I think I have some time for questions, so I will bring those up and find. Oh, why is this not coming up? Ah, here we go. Okay. First question is, how do you inject variables into Helm? Where do you store and where do you add them? How do you make upgrades of your software using Helm? Okay. So in terms of variables, let me see if I can. There is a section called variables. Let me see if I can bring it up and show you. But in terms of how do you make upgrades of your software using Helm? So what we ended up doing was we wrapped Helm up into a Docker container and had an upsert function. So we didn't even Helm has an, if you know Helm, there's a Helm install for your initial install, and then there's a Helm upgrade. Well, we wrapped it in a bash script and put it into a Docker container with an upsert function. So what it does is it handles it for the engineers, where it says, okay, let me see if there's a deployment with that name. If there is, we're going to use upgrade, and if there isn't, we're going to use Helm install. So that's how the upgrades work. Let me see if I can find for you how the things. Okay, another question. What are you using for CI/CD? We're using Jenkins pipelines. We've done a tour of CI/CD. We used Circle CI for a while, and while that a lot of engineers liked it, from an operation standpoint, it wasn't great for us. Like, the maintenance of it and having to do upgrades involved significant downtime. Like, it just wasn't. Maybe if we used the self-hosted version, maybe if we used the hosted version, it would be better. Um, so yeah, that's kind of. And then Jenkins, it's relatively standardized. The fact that we're able to get it running on Kubernetes, and for there's more community support. We did the thing where we had vendor support, and it didn't pan out for us. So that's kind of why. The other half is that some of the better supported commercial solutions were very expensive, and they were charging by seats, and given our developer seat uh, count, and also like what our organization is, just didn't work. Dimitri asks, what was your migration time? How much engineer hours, weeks it took in your case? How did you do this? Did you start with a prototype? We did start with a prototype, and it also helped that we had a team that was excited about, just that they were so fed up with the Beanstalk deploy time, um, that they were highly motivated. So we used them. Thankfully, they had lots of applications. I would say that in the beginning, the the time it took was really um, about about a day of training, and then it's not really like it would probably be a couple of days to for an engineer to be fully turned up on this new way of operating, and so that's really what it was. It really wasn't that long. And yeah, we did start with a prototype. It did help with a team where, they were like, okay, we're ready. Like, we want this. Like, and they were very motivated. So they became our prototype, which was great because it was a living prototype as opposed to something we created. David asks, any thoughts on deploying Kubernetes on physical machines? Um, it's I don't imagine that it would be much different. I think the thing that you wouldn't be able to take advantage of is the spot instance thing, being able to scale up and scale down. But presuming if you have a relatively stable workload, you could do that. I Cops, like, we use cops, and that wouldn't help you. I think it's going to be a little more complex. When we looked at the different ways of bootstrapping Kubernetes, kubeadm, and the other things, cops was the easiest way. So I think if you're using it on bare metal, it'll be a little more difficult. What you use on the network top layer, is it still ELB? If yes, why not ALB? Um, Honestly, we are using ALBs and EKS because they support that by default. We do need to upgrade our ELBs on the main clusters, on the Kubernetes application clusters. And honestly, it really, at the time, it was when I was creating the Terraform script for the infrastructure, like, I just didn't think of it, and then it stuck, and then uh, but we have plans to migrate that. There's not really any reason why except like kind of lack of forethought. So, and I think that's all the questions, unless anyone has other ones. Let me bring this. So there's my contact information. You reach out as my email and LinkedIn. Sorry, I should have put this up sooner when I was answering the questions. But thank you very much. I hope you enjoy the conference and stay safe, everyone. Thanks.